The programmer versus software engineer issue confuses many aspiring technology professionals. Programmers and engineers apply advanced technical skills to create computer programs, and their roles overlap in many ways. While the two professional roles share similar responsibilities and educational backgrounds, they generally differ in their methods and outcomes. Aspiring software professionals may confuse the two positions, but programmers and engineers typically handle different steps when creating applications. In performing their core functions, programmers collaborate with other team members, including software testers and quality assurance (QA) analysts. Programmers mainly work for specialized computer design companies, though some maintain permanent in-house positions in industries including finance, insurance, and manufacturing. Programmers typically train by earning bachelor's or master's degrees in computer science or information technology. Others develop targeted skills in compact career training programs known as coding bootcamps. Aspiring programmers can also build the necessary knowledge and skills through self-directed learning. Software engineers apply engineering principles to creating applications. Engineering principles include a general set of logic-based and process-based concepts used to guide product and system development. One of the defining aspects of the software engineer versus programmer issue is that engineers generally interact with a broader set of collaborators. These include clients, other engineers, programmers, cybersecurity specialists, and non-technical professionals in management or executive roles. A software architect is a software engineer responsible for high-level design choices related to overall system structure and behavior. AI can automate repetitive tasks, such as testing, debugging, and code reviews. If you even hire remote developers, they can focus on core tasks and automate the repetitive ones using AI. AI algorithms can analyze code and detect errors that may be missed by human developers, leading to more reliable and accurate software. AI can help developers write higher quality code by providing suggestions and identifying potential issues before they become problems. By automating many development processes, any AI software development company can release faster, reducing the time and cost associated with development. AI can provide developers with new insights and ideas they may not have thought of otherwise, leading to more innovative solutions. Pair programming is the practice of pairing up to work on programming tasks. Most people imagine two humans seated at the same computer, sharing the keyboard. But with the increasing popularity of AI platforms, it's now possible to pair program with artificial intelligence. Successful pair programming relies on successful communication as much as programming skill. The premise is that when working on a complex task, two heads are better than one. The most important reason to pair program is that it often produces better solutions than either developer could have produced on their own. Problems are picked up on earlier and potential bugs are identified by two people instead of one. Before the pair settles on an approach to a particular problem, they discuss, evaluate, and talk through any trade-offs involved. Solutions are evaluated up front rather than after they've already been implemented. Github Copilot transforms the developer experience. Backed by the leaders in AI, Copilot provides contextualized assistance throughout the software development lifecycle, from code completions and chat assistance in the IDE to code explanations and answers to docs in GitHub and more. With Copilot elevating their workflow, developers can focus on more value, innovation, and happiness. GitHub Copilot suggests code completions as developers type and turns natural language prompts into coding suggestions based on the project's context and style conventions. GitHub Copilot is trained on all languages that appear in public repositories. For each language, the quality of suggestions you receive may depend on the volume and diversity of training data for that language. For example, JavaScript is well represented in public repositories and is one of GitHub Copilot's best supported languages. Languages with less representation in public repositories may produce fewer or less robust suggestions. GitHub Copilot is available as an extension in Visual Studio Code, Visual Studio, Vim, NeoVim, the JetBrains suite of IDEs, and Azure Data Studio. GitHub Copilot Chat is a chat interface that lets you interact with GitHub Copilot to ask and receive answers to coding-related questions within github.com and supported IDEs. The chat interface provides access to coding information and support without requiring you to navigate documentation or search online forums. Copilot Chat is currently supported in Visual Studio Code, Visual Studio, and the JetBrains suite of IDEs. GitHub Copilot Chat can answer a wide range of coding-related questions on topics including syntax, programming concepts, test cases, debugging, and more. GitHub Copilot Chat is not designed to answer non-coding questions or provide general information on topics outside of coding. GitHub Copilot Chat works by using a combination of natural language processing and machine learning to understand your question and provide you with an answer. This process can be broken down into a number of steps. Artificial intelligence, AI, systems have developed rapidly in the last decade. In 2016, AI beat a legendary player at the game of Go. Today, AI can recognize speech and images better than humans, and can pass tests like Amazon coding interview questions and business school exams. A study by Google found that AI can generate code that is of comparable quality to human written code, but at a much faster rate. The study found that AI can generate code up to 100 times faster than humans. This means that AI can help companies to develop software more quickly and efficiently. AI has advanced to the point that it can perform several coding tasks. AI coding assistants can auto-complete sections of code, check it for bugs, translate it from one coding language to another, and write code from plain language prompts. Some AIs can perform just as well as an average human in a coding competition. They can also complete some of the challenges that applicants for development jobs at large tech firms face. While this growing ability is impressive, it's far from perfect. Issues like errors and security flaws are some of the hurdles that AI programmers face as they work to refine these tools. What will this mean for the future? GitHub Copilot's website predicts that AI tools could help eliminate more repetitive tasks to allow developers to be more productive, reduce manual tasks, and help them focus on interesting work, but that they won't be a substitute for the problem-solving and ingenuity of human developers. They could also help make working and coding more accessible for more people. Research has found GitHub Copilot helps developers code faster, focus on solving bigger problems, stay in the flow longer, and feel more fulfilled with their work. 74% of developers are able to focus on more satisfying work. 88% feel more productive. 96% of developers are faster with repetitive tasks. Generative AI coding tools are transforming the way developers approach daily coding tasks. From documenting our code bases to generating unit tests, these tools are helping to accelerate our workflows. However, just like with any emerging tech, there's always a learning curve. As a result, developers, beginners and experienced alike, sometimes feel frustrated when AI-powered coding assistants don't generate the output they want. Feel familiar? What's a prompt and what is prompt engineering? Prompts are code blocks, individual lines of code, or natural language comments a developer writes to generate a specific suggestion from GitHub Copilot. When prompting GitHub Copilot, think of the process as having a conversation with someone. How should I break down the problem so we can solve it together? How would I approach pair programming with this person? Once you communicate your main goal to the AI pair programmer, articulate the logic and steps it needs to follow for achieving that goal. GitHub Copilot better understands your goal when you break things down. Imagine you're writing a recipe. You'd break the cooking process down into discrete steps. Not write a paragraph describing the dish you want to make. Let GitHub Copilot generate the code after each step, rather than asking it to generate a bunch of code all at once. Give GitHub Copilot an example or two. Learning from examples is not only useful for humans, but also for your AI pair programmer. The LLMs behind generative AI coding tools are designed to find and extrapolate patterns from their training data, apply those patterns to existing language, and then produce code that follows those patterns. Given the sheer scale of these models, they might generate a code sequence that doesn't even exist yet. Just as you would review a colleague's code, you should always assess, analyze, and validate AI-generated code. Welcome to GitHub Copilot in Visual Studio Code. The only typing I do in this example is typing in the comment. GitHub Copilot provides autocomplete style suggestions from an AI pair programmer as you code. You can receive suggestions from GitHub Copilot either by starting to write the code you want to use, or by writing a natural language comment describing what you want the code to do. Convert comments to code. GitHub Copilot uses a special version of GPT-3 that has been trained on a large body of public source code. It is as good at writing natural language as it is at writing code, so in fact it can complete your comments for you. In the example below, we first let it complete our explanation, and then, line by line, we tab through the code that does what we just said in English. Once you communicate your main goal to the AI pair programmer, articulate the logic and steps it needs to follow for achieving that goal. GitHub Copilot better understands your goal when you break things down. Imagine you're writing a recipe. You'd break the cooking process down into discrete steps, not write a paragraph describing the dish you want to make. Just how conversation is more of an art than a science, so is prompt crafting. So, if you don't receive what you want on the first try, recraft your prompt by following the best practices above. We iterated on the prompt to be more specific, but we still didn't get the exact result we were looking for. This is a good reminder that adding specificity to your prompt is harder than it sounds. It's difficult to know, from the start, which details you should include about your goal to generate the most useful suggestions from Github Copilot. That's why we encourage experimentation. When entering a prompt in the chat window to the left, the AI knows you are asking a question about the code opened in the text window. The AI suggests prompts, in blue, at the bottom of the chat window. In this example, the prompt suggests adding input validation to the code. Not only does the AI provide code, but it explains the new code it is adding. You can scroll through the AI conversation and even save the conversation if desired. The AI uses the whole conversation in the chat window plus the code in the editor to build a context which is used to make recommendations. In this example, the AI remembers that you accepted the recommendation for input validation, so it suggests validating the operator as well. Next to each AI result is a thumbs up or thumbs down. This allows you to provide positive or negative reinforcement to the AI. When prompting GitHub Copilot, think of the process as having a conversation with someone. How should I break down the problem so we can solve it together? How would I approach pair programming with this person? The rise of artificial intelligence, AI. AI is already having a major impact on the world of programming, and this trend is only going to accelerate in the years to come. AI-powered tools will make it easier for programmers to write code, and they will also be able to automate many of the tasks that are currently done by humans. For example, AI can be used to generate code, find and fix bugs, and even design new software applications. This will free up programmers to focus on more creative and strategic tasks. The growth of low-code and no-code platforms. Low-code and no-code platforms make it possible for people with no programming experience to create software applications. These platforms are becoming increasingly popular, as they allow businesses to quickly and easily develop the software they need. Low-code platforms provide a drag-and-drop interface that makes it easy to create user interfaces and connect to data sources. No-code platforms take this a step further and allow users to create entire applications without writing any code at all. This trend is likely to continue in the years to come, as more and more businesses look for ways to reduce their reliance on programmers. The increasing demand for skills in new programming languages. As new technologies emerge, new programming languages will be developed to support them. Programmers who are able to learn and master these new languages will be in high demand. For example, the rise of artificial intelligence has led to the development of new programming languages like Python, and these languages are well suited for data science and machine learning, two areas that are expected to grow rapidly in the years to come.